Welcome back to Maths Made Easy. Today we'll be doing exponents and surds for grade 11. Now let us take a look at question 2.1. The question says simplify the following without the use of a calculator. So here is the first question, 2.1.1. It is given to us as 2 to the power of n plus 2 multiply by 4 to the power of n plus 1 all over 8 to the power of n minus 1. So now taking a look at this, I see exponent here, I see exponent here, and I also see exponent here. So meaning that as soon as I come across so many exponents, I know that this has got to do with the laws of exponents. Now, what do the laws of exponents often say? Whenever they start, they say when bases are the same. When bases are the same, meaning that the first step that I'm going to do here, I'm going to ensure that my bases are the same so that I can be able to deal with the exponent, because the laws of exponents says when bases are the same all the times. So now, how do I get my bases to be the same? I look at this number, it's a prime number, so I cannot write it in terms of any other base besides 2. I look at 4. 4 can be written as 2 to the power of 2. So I change 4 and I write it as 2 to the power of 2. And then that n plus 1 was the exponent that was out there. I look at 8. This 8 right here can be written as 2 to the power of 3. So I change it, and then we had n to the power of n minus 1 out there. Then we continue with our question. We simplify it. Now how do we simplify? We have 2 to the power of n plus 2. And then when you come to this one, we know that the laws of exponent says exponent raised to another exponent, you multiply the exponent, meaning that I'm going to multiply this exponent by this one. It gives me 2n. I multiply this one by that one. It gives me plus 2. And then underneath here, exponent to another exponent, I need to multiply the exponents as well. So it's going to be 2 to the power of 3n minus 3. And then when I take a look at my numerator, there is something that I see. The bases are the same here. We have multiplication. The first law of exponents says when bases are the same with multiplication, you add the exponent. Now I need to add the exponents. So I'm going to have 2 to the power of n plus 2 plus 2n plus 2. Underneath there, it is still 2 to the power of 3n minus 3. So I hope we are still together. From here, we just add the like terms. 2 to the power of what? N plus 2n is 3n. 2 plus 2 is 4. Underneath here, we have 2 to the power of 3n minus 3. Again, there is something that I see. The bases are the same. We have division. The law of exponents says when bases are the same with division, we subtract the exponent. But how do you subtract the exponents? The upper exponent subtract the lower exponent. Now, this is where a lot of learners make mistakes. When they subtract, they forget to put in this one in brackets. Why do I put it in bracket? Because it is a number, it is an expression that consists of 2 terms. But if it was just one term, there would not be a need for me to put it in brackets. So this helps me to avoid mistakes. So it's going to be 2 to the power of 3n plus 4 minus 3n negative times negative gives me positive. And then take a look at what happens. 3n minus 3n is 0. 4 plus 3 is 7. So my answer here is 2 to the power of 7. So my answer becomes 2 to the power of 7, which is equals to 128. That was the very first question. Now let us move on to question 2.1.2. Let us copy it down. Now question 2.1.2, here is how it goes. we are given the square root of x plus the square root of 2x minus 1 dot, which means multiply by another square root of x minus the square root of 2x minus 1. When you take a look at it, it looks very complicated, when in actual fact it is not. So now how do you deal with it? Let's take a look at it. Before you can attempt it, there is something that you must recall or remember, which is laws of sets. Laws of sets. What do they say? They say that the square root of a multiply by the square root of b is equivalent to 1 square root the square root of a times b. So meaning that when I have square root of a multiplied by the square root of b, I can just write 1 square root and multiply these two numbers underneath 1 square root. So let's see how do we deal with the equation that we're dealing with. Let's try and attempt it. I have a square root multiplied by another square root. The laws of sets say I can write the square root alone. I can make a very huge square root and multiply everything that was under the square root, meaning that I multiply the square root of 2x minus 1 by what was under this square root, which is x minus the square root of 2x minus 1. This is just the laws of sets. Then we continue with our equation. From here, it is the simple algebra. We are foiling underneath the square root. So meaning that I multiply this x by this one, it gives me x squared. I multiply this by this, it gives me plus, oh sorry, not plus, because negative. Then this one is positive, this one is negative. When I multiply them, they give me minus x, the square root of 2x minus 1. This one times this one, they give me plus x into the square root of 2x minus 1. Then lastly, negative times positive is negative. Square root multiplied by square root, I think by now we know that that means square root times square root, it is the same as squaring that square root. So meaning that this is going to be 2x minus 1. The square root goes away. Or maybe let me write it here so that everyone can see. I don't want anyone to be lost. So it means that square root of 2x minus 1 multiplied by the square root of 2x minus 1. This is the same as you write it under 1 square root and then you multiply 2x minus 1 by 2x minus 1. So this is the square root of 2x minus 1 squared. Meaning that this cancel these ones out and then we are left with 2x minus 1. I hope it makes sense. So that's how I got the 2x minus 1. Then I continue with my equation. I still have that big square root over there. This one right here cancel out with this one. This one is positive, this one is negative. So they are going to cancel each other out. I'm left with x squared. This times this is minus 2x. This times this is plus 1. But when I take a look at this, I see a perfect square trinomial. So meaning that I can factorize it. When I factorize it, this is x, oh, x, two numbers that when I multiply gives me 1, but when I add gives me 2. Those numbers are 1 and 1, and then minus minus. So meaning that the answer to this is x minus 1 all squared, which is just x minus 1. So the answer to that question, it is x minus 1. We are now moving on to question 2.2. It says given p is equivalent to the square root of 5 over x plus 2 plus x over 3, and then 2.2.1 says for what values of x will p be a real number. So before we can try to answer the question, let us take a look at p. What is p? P is the whole of this equation. So when do you have real numbers and non-real numbers? You have a real number if you have a square root that contains a number here greater than 0. It means if the number under the square root is greater than 0, we say this is real. But if the number below the square root is negative, this is positive, this is negative, then the answer will be non-real. So for p to be a real number, what is under the square root should be positive. So that is what we are going to focus on. So let's answer it. So we are going to focus on the number that is under the square root. So what is under the square root here is 5 over x plus 2. So for p to be real, 5 over x plus 2 must be positive. But we know that 5 is always positive. So our focus should be on what? On x plus 2. X plus 2 should be greater than 0. So for p to be real, x plus 2 should be greater than 0, meaning that the value of x should be greater than negative 2. So we are going to have p being real when x is greater than 2. Now let's move on to 2.2.2. Now 2.2.2 says show that p is rational if x is equals to 3. Show that p is rational if x is equals to 3, meaning that you go to your equation of p, and then wherever you see x, you plug in the value of x, which is, they gave us how much? 3, right? So you go to that equation, wherever you see x, you plug in 3. So they said p is equals to the square root of 5. It was x here, I put in 3. It was x here, I put in 3. So before you answer, you must know what does it mean to be rational. A rational number is any number that can be written in the form of a over b, meaning a number that can be written as a fraction. So p will be equivalent to the square root of 5. 3 plus 2 is 5, plus 3 over 2. This is 1 plus 3 over 2. Then when I simplify it further, it gives me how much? 5 over 2. By doing this, I've shown that p is rational. So p is rational if x is equal to 3. You can see that our p is written as a over b, is written as a fraction. And then the very last question says calculate the sum of the digits of 2 to the power of 2015 multiplied by 5 to the power of 2019. But of course, you cannot just go straight to answering the question without understanding what the sum of the digits are. For example, if the question had said calculate the sum of the digits of 2 multiplied by 9, for example, I would first have to multiply 2 by 9. It will give me 18, and the sum of the digits will be, here's the first digit, here is the second digit. So the sum of the digits will be, sum of digits will be 1 plus 8, which is 9. I'm not sure if it makes sense. Let us try with another example. If the question says calculate the sum of the digits of the following, let's say 2 to the power of 3 multiplied by 5 to the power of 2. This will be 2 to the power of 3 is 8. 5 to the power of 2 is 25. When you multiply them, they give you, let me quickly multiply them. They give me 200. Then sum of digits will be, if I add this digit, this one, and this one, my answer will be 2 plus 0, which is just 2. So the sum of the digits will be 2. So now let us answer the question that is given to us. The question here says, calculate the sum of the digits of the following. Taking a look at it, even if you try to put it into your calculator, you do not get to the answer that you want. But there is something that you can do. What is it that you can do? Laws of exponents. Laws of exponents says that a times b to the power of m is equals to a to the power of m multiplied by b to the power of m. So we can apply something similar to this here. So first step, I have 2 to the power of 2015 multiply by 5 to the power of 2019. So I'm going to try and write my equation in such a way that it accommodates, in such a way that, you see, this is 2015. I'm going to write it in terms of 2015 and another number. It's going to be 2 to the power of 2015 multiplied by 5 to the power of 2015 plus what? Plus 4. So meaning that this is 2 to the power of 2015 multiply by 5 to the power of 2015 multiply by 5 to the power of 4, because the laws of exponents says when the bases are the same, we add the exponents. I hope we are still together. Now these two right here, they are according to the laws of exponents there. What do they say? The laws of exponents says whenever I have a number like this one, whenever I have a to the power of a particular exponent, b to the power of a particular exponent, I can put them under one bracket and raise them to the same exponent, meaning that this is 2 multiplied by 5 to the power of 2015. Again multiply by 5 to the power of 4. Now what is 5 to the power of 4? 5 to the power of 4 is nothing much but 625. Now what is this? This is 10 to the power of 2015 multiplied by 625. So breaking this one down, one is wondering, how do you get 10 to the power of 2015? How do you get to solve it down? I think it's pretty much simple. 10 to the power of 1 is 10. 10 to the power of 2 is 10 times 10, which is 100. 10 to the power of 3, let me write it down, is 1000. 10 to the power of 4 is 1000. I think you start to see a pattern here. 10 to the power of 5 is 100,000. Meaning that if the exponent is 1, you only have 1 0. If the exponent is 2, you have 2 zeros. If the exponent is 3, you have 3 zeros. If the exponent is 4, you have 4 zeros. Exponent is 5, you have 5 zeros. The pattern continues in that particular way. So in this case, we're going to have 625 multiply by this number 10 with so many zeros. The zeros continues, but you'll have 215 zeros. So when I multiply this will be nothing much but 625 0 0 0 0 0 0 0 0, and we know that the zeros will be 2015 in numbers. So when I calculate the sum of the digits, it will be 6 plus 2 plus 5 plus all of those zeros, but you know that zeros, if you keep on adding the zeros, you get nothing. So it's going to be 2. 6 plus 2 is 8. 8 plus 5 is 13. So the sum of the digits will be 13. Thank you so much for being with us throughout the whole video. See you in the next video.